Yeah. Good afternoon
Yes,
to
ma'am.
all SATEB. All three classes are all together now.
Yes, ma'am.
Yes, yes, ma'am.
Yeah. So why objective of combining all these three classes? Because the subject is important. If we talk about the second year should know about it so that they can start their journey in that point. About third year is at middle level. They are at embedded system, and final year they are at IoT level. So that's why all three classes are combined here to know about the IoT. Second objective is for second year, you are having a PBL subject in second sem, that is problem based learning. So how to address the problem, how to work on that. This area we can cover, or I'm going to address some of the problems that you can work on through this session. For a third year embedded system, we are learning microcontrollers. So what is the role of microcontroller in IoT, that we need to understand. And for final year, they are going to develop projects as their curriculum. And also they are having IoT subject in their curriculum as theory and practical. So they can know components of IoT, which are the projects that can be developed using IoT. So this is the objective, that all three classes are combined together to know about the IoT and embedded system. So let us start with components of embedded system. So some of the component already known to second year level students and third year level and final year, no complete things. So see this diagram, if it is visible to you. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So starting with real world measurement. Real world measurement means the physical quantities we are dealing with in real world. So to measure the physical quantity, what we require? What we require to measure the real world quantity or physical
Sensors.
quantities? Yes,
Sensors.
correct. Which class? SATEB. Which class?
TEOBE.
Okay, very good. So it's these are the sensors. Sensors can be used to measure the physical quantity or to deal with the real world measurement. So whatever the data, whatever the physical quantity we collect with the sensor, it is in which form? It is in which form? Output of sensor is in which form?
Electrical.
Correct. It is in the electric form. We get the electric signal, that is, it may be voltage or current. Okay. Now, what is the thing? Whatever voltage or current level we get, it is not significant to process. We need to amplify. In other language, output of these sensors are weak. Okay, so we need to amplify and process it further. That is done by the transducer or signal processing. Further signal processing. Two type of things are there. We need to amplify the weak signal, and second, if noises are there, we need to remove those or reduce those noise. Next is the analog interfaces. So this signal is available into analog form now after amplifying the signal and removing or reducing the noise. So to process it with the computer or microcontroller or any processor, we need to have this signal in digital formats. So that's why ADC is there. ADC stands for, yes, final year or diploma
Data
students.
converter.
Analog to digital converter.
Correct. It is analog to digital converter. So now signal or data taken from this real world is available in digitized form. That is 1 0. Okay. So with microcontroller, we can process that data as per the application, as per the requirement, and two action or two output of the processing is there. Either we required that digital signal back into the analog form, like your ECG signal and all, or second, you require some actuations. Okay, so likewise controlling the motor, operating the pumps, indicating some light, sound. So this output of this PWM is actuator to activate something by means of the mechanical, electrical, thermal, sound and light, which is again nothing but the, it can be given back into the physical. So this is the closed loop system and which is called as the embedded system. Now, when this particular system is developed for a single or specific application, it is called as a embedded system. The application is embedded into this particular microcontroller. That's why it is called as the embedded. So it is the dedicated system. It is not a general purpose system. Hence it is called as the embedded system. Now what are the components of this embedded system which can measure this real world measures? So first component of embedded system which measures this real world measures are the sensors as discussed. So here is the tabulated form where physical quantity is given and which sensor can be used to measure that physical quantity. So to measure the sound, microphones are there. Now you have to go through different website to know which are the microphones, what are their data sheets available, what is their cost, detail about this microphones you have to do. For every sensor, this activity you have to do. Take it as an assignment. Whatever sensors are there, you need to find out the range, complete range. Let us say for sound, microphone is there. And all the range of microphone, their specification, their comparative study, and that cost that you have to do. Second, pressure, mass, force. Strain gauge, force sensitive resistors. To measure the pressure, mass, force, strain gauge is used. Again, same thing. Go to the different websites, manufacturers who or suppliers who supplies the strain gauge. Try to know the part number. Part number is that when you go to the market, how should you ask for strain gauge? You can come to know from the data sheets. So what is data sheet? It is already discussed with third year, final year. For second year, we'll discuss at the time of PBL. Okay. So for second year, you just learn it, you just listen to it and try to grasp the things, though you will not get the complete things. Okay. Again, if you are a diploma student, you may understand the things. Next is the temperature. For temperature, thermistor, thermocouple, and some ready integrated circuits are available. Ready ICs are available. For distance, ultrasound, laser, and infrared light sensors can be used to measure the distance. Now we are implementing one project where we want to measure the water level. So we are trying to measure it with help of the ultrasounds. Again, for the laser, you may see the application with help of the laser. Nowadays, civil engineers, they measures the distance when they take the measurement of the walls or room. They, or you can say architect or interior designer, they use this application. They take the measurements with help of the laser. Likewise, there are the many applications. So again, try to map the application of the sensor. Next is the flow. Water flow, fuel flow. So any type of flow, if you want to measure, Doppler ultrasound sensor is there and flow probe is there. Okay, so try to know more detail about it. To measure acceleration, accelerometer is there. Can you anyone give any example of accelerometer where you can find it? Anyone? Is it available
Bike
on?
speed meter.
Yes. Huh?
Bike speed meter.
Bike speed meter. Okay. Anyone? Is it available in our mobile?
Yes, ma'am.
Yes.
Okay. So in this way, try to explore whatever sensor we are mentioning here. where they are used, what we can do with these sensors. Based on that, you can develop your projects, or based on that, once you know the sensor, their purpose, their application, then you may able to use this sensor to give solution to any application that you are going to develop. It may be your project, or when you go to industry, if you ask to give some solution, you can map in your mind which sensor can be used. So continuously try exploring the sensors, where that can be used, what are the technical specifications, like that. Okay. So light sensor is the most famous sensor nowadays. Lot of things can be done with the cameras. So this is the most useful or most proven sensor in the market nowadays. Biopotential, it is a silver chloride electrode. So these are the sensor. Likewise, if you know more sensors, just put it in the chat box. Do you know more sensors? Say yes, no. I want with respect to physical quantity. Can you give any additional physical quantity that we can measure? I've tried to cover this many. Do you get anything to add? Something is there in chat box. pH sensor. Okay, correct, Shubhangi. So, which are the pH sensor? pH is the sensor. What is the physical quantity actually? We measure pH, means what we measure? Means physical quantity we measure. Okay, so likewise, you explore the data sheet should be reached at, say, let us say hundreds and all. Okay, you can't reach 100 because we need to explore the physical quantity also, but try to enhance this data set of physical quantity and the sensor used. Like Shubhangi has given the pH. So explore the application and map the sensors. So next component of this embedded system is transducers. Okay, so what are the transducers? They convert the physical quantity such as the temperature, pressure into electrical quantity, which is nothing but your sensors, or measuring electrical quantities directly. They collect the data from physical world. We have seen the sensors are nothing but the transducers. The most commonly used transducers are this RDS, thermocouples, thermistor for temperature measurement, photosensors for light measurement, strain gauge, piezoelectric transducer for force and pressure measurement, microphone for sound, potentiometer, LVDT, optical encoder for position and displacement measurement. Next to that is the signal conditioning unit. So as we discussed earlier, output of this transducer or sensor is not that much capable to process directly. Either they are weak in the amplitude or they may have some noise. So we have to go for the signal conditioning. What signal conditioning unit is? The signal produced by the transducer may or may not very suitable for our system to work properly. Why? It may be very weak, very strong, or have some noise. Yeah, I'm getting noise. Who is there? Mukesh Mahajan sir. Mahajan sir, please mute yourself. Yeah, thank you. So, as discussed, it may not be used directly. Why? Because this may be very weak, very strong, or may have some noise. So to convert this signal into more suitable form, we have to do amplification or filtration. Amplification to enhance the signal amplitude, and filtration is to remove the noise. So this is nothing but the signal conditioning. So the signal conditioning unit converts electrical signal into the most suitable form. That is, after amplifying it to the as per the required level and removing the noise, now we can use this signal for processing. So this is ready signal for processing, but in analog form. To process it with processor or microcontroller or computer, we need to have this signal in digital form. So next component of embedded system is ADC, that is analog to digital converter. So the data is converted into digital form by ADC as name indicates. After the conversion of data into digital form, it displayed with help of the numerical displays, panel meters to monitor the complete system. So there are the different purposes to have the signal into the digital format. Also, data can be either permanently or temporarily stored, recorded according to the requirement. So this is the purpose why we want to convert or have the data in digital format. Which are the performance measures of any embedded system or ideal characteristics of the embedded system? It must collect the necessary data at correct speed. As we are collecting the real-time data, so this speed should be accurate. So we have to select the sensor accordingly. We have to select the ADC accordingly. How we measure or how we define accuracy of ADC? Anyone, final year students? How? Which are the characteristics of the ADC that can be considered while selecting it? Anyone? Okay. First of all, precision. What does it mean by precision of ADC? Precision of ADC. It is related to number of steps, right? Smaller is the step size, more is the precision. You can say, you can map the minute incoming voltage into the digital format. So again, this step size depends on what? Number of inputs. Okay. So if here is the 8-bit ADC, 2 raised to 8 step size you will get. If your 10-bit ADC, you can get the 2 raised to 10 step size. So in this way, what is bit ADC is, more is its precision. Second feature or second thing that ADC while selecting the ADC is the conversion time. So at what time it converts analog signal to digital? It is the most important point. So these two parameters should be considered while selecting any ADC. First one, its step size or precision we can use. So higher is the precision, more accurate conversion we get with help of the ADC. And second is what? The conversion time. So if these two parameters are satisfied, then we can satisfy this criteria. It must collect necessary data at correct speed. Next, it must use all the data efficiently to inform the operator about the state of the system. So again, the conversion time and the processing should be done accurately. It must monitor the complete system operation to maintain online optimum safe operation. So the embedded system should be like that. It should monitor the complete system operation. Why? Because at every stage, whatever the intended operation, whether it is getting correct, then at the end, what are the complete application we are intended to do will be meet. The expectation of the embedded system can be fulfilled if we have a checkpoint at every stage. So there should be some monitor at each stage so that we can get the complete optimum operation. Second is the safe operation, means there should not be any hazards like short circuits and all. So it should be perform the safe operation. It must be able to summarize and store the data for the diagnosis of the operation and record purpose. So what is the further use of this embedded system? We want to either store the data or we want to process it for particular further operation, or we want to record. Again, based on the record, we can do the analysis of the recorded data and we can give some inference or some prediction about the system. It must flexible for future requirement. This is very important. In last lecture itself for third year, we have discussed this flexibility criteria of the microcontroller. So embedded system, microcontroller is the heart of any embedded system. So flexible means what? As it is embedded, it is fixed, it is one time. Okay. Still we have to be flexible means what? If we develop any embedded system and we intended or as per the user requirement, we need to adopt or we need to add some more features, our system should be able to expand that. So it shouldn't like that we have to redesign the system if new thing is to be added. So for that, to have the flexibility, which are the points to be considered? We have to keep some ports free so that we can connect more IO. We have to think that which resources can be available on that microcontroller, which can be used to fulfill that particular requirement. So to have the system flexible, we have to select such a microcontroller which can have more IO input-output pins and the resources which can meet this advanced requirement of the embedded system. It must be reliable and not have downtime of more than 0.1%. So what is the chance to get it down? Only 0.1%. So it should be reliable because we are going to use in real time. So system should not get fail. That's why we have to test it many times to ensure its reliability. It must provide an effective communication system. Effective communication means every time whatever blocks are there, the communication should be so that it's not a digital analog communication. It is the exchange of signal. Communication is basically what? Exchange of signals. So at every level, let us say with the sensor to ADC, what is the communication happening is conversion of data from analog to digital. So that is the communication takes both at that place. So then ADC to microcontroller, converted data is available to microcontroller. That is the exchange of signal that ADC gives microcontroller that yes, data is converted, available with me, you can take it and further process. So such type of communication take place between the each blocks of the embedded system. And we need to understand that communication. Now, next is what things we have to keep in mind when designing the embedded system. First slide was related to what? Performance measures. Our embedded system, which embedded system we develop, should perform or should meet these particular points by means of its performance. Next is while designing any embedded system, hope you understand the word embedded system now. It is the application developed with help of any microcontroller or microprocessor, but for dedicated or specific application. So whatever application we are developing using embedded system, while design that embedded system, which parameter we need to consider? First, accuracy and resolution. So resolution is nothing but our ADC, as we have said, it should give the correct output as per the input. So these are the synonyms, accuracy and resolution. Number of channels to be monitored. How many IO devices you have used, it need to be monitored. If data is incoming, whether it is coming with the correct speed, whether it is coming accurately, and second, processed data for display. Likewise, number of channels to be monitored. How many channels means how many IO devices you are using, that we have to think while designing it. What parameters we are taking from the real world, and what actuation we have to take place after processing the data. That is nothing but the number of channel to be monitored. Analog or digital signal. Which signal you want, analog or digital after processing? Single channel or multi-channel, whether your system needs only one sensor or you are processing many sensors. So if you are dealing with the many sensor, you need a multi-channel, and if you are dealing with the single, then it is a single channel. Sampling rate per channel. Who can give me this sampling rate per channel? What is sampling rate? Anyone, whatever sampling rate you have understand in communication or any subject.
Number of samples per second.
Okay.
Or pulses.
Okay. Now can you relate it to the microcontroller? It is basically again related to ADC.
Speed of ADC, yes, ma'am.
Yeah. So incoming voltage is sampled. It is steps are there. So that step or that voltage is assigned to the incoming analog voltage, and then it will be 0 or 1. It is mapped in that way. So sampling rate per channel. Signal conditioning requirements of each channel. So if whether it requires amplification or filtration of noise, it should be processed correctly, or we have to ensure it. Nowadays ready modules comes in the market which are there with the signal conditioning. Directly digitized data is available with that sensor, and we can directly connect it with the microcontroller. But initially the sensor required the signal conditioning. If required the signal conditioning, we have to take into mind while designing whether the signal conditioning unit meets the proper voltage requirement and can it remove the noise. Last and important is the cost. In last lecture, I have given the example of this cost. One startup came to me with one application, and he has used a very costly microcontroller. So with which the cost of the product goes high, and the market is not ready to accept the application with high cost. Always we have to keep into mind when we design any embedded solution, it should be cost effective. So you have to make it cost effective, you have to work at every stage. Low cost sensors, low cost ADC. Now ADC is also available on chip with the microcontroller. No separate ADC is required. So cost of ADC is again reduced. Again coming to the microcontroller. So its cost should be the as per the requirement, means what exactly we are processing, whether that particular microcontroller meets that requirements. That's why we have discussed the criteria of selecting the microcontroller, which directly connects to all these design parameters. And microcontroller is the heart of any embedded system. So it should be, to make it cost effective, at each stage we have to compute the cost and make it cost effective. And we can't compromise. If we compromise with the cost, it's not like that. It should hamper the efficiency of the embedded system. So embedded system should be efficient as well as cost effective. Efficient means whatever the purpose, whatever application we intended to do, it should meet the particular application or purpose of designing 100% and with low cost. That's why effective and efficient. This is any embedded system. It starts from the sensor. These are your transducer or sensor section. This is your signal conditioning, which is nothing but the amplifier. After signal conditioning, it is given to the ADC. Now here you can see it is directly connected to ADC where no signal conditioning is required. So at that time it can be connected directly to ADC. So this ADC converts this signal into the digital form and give it to the microcontroller. Microcontroller processes it, and after processing, as per the application of embedded system, either it will be display, it will store that data, Also, it can be make interactive with the input devices, that is a keyboard. Based on that, the action can be activated. It may be a switch also, and PC interfacing. You can give this data to the PC for further processing also. Nowadays, there are many softwares are there like MATLAB and Python based, which can process this data when once it come to the PC. So this is nothing but the embedded system, and microcontroller is the heart of any embedded system. Coming to the IoT, what is the relation of this embedded system to IoT? That is our today's topic of discussion, embedded system in IoT perspective. What is the role of embedded system is IoT? So this is the IoT. Nowadays, every one of you from second year to final year know this term IoT, Internet of Things. Now, Internet is very known to you. We need to understand these things and what is the Internet of Things. Okay, Internet is known to you. We understand the things and then we relate this Internet of Things. So what it refers? It refers to a system of interrelated, interconnected objects or things. That's why the word thing is used. Things is nothing but the object that are able to collect and transfer data over a wireless network without human intervention. So this is the IoT, and here from this pic you can see these are all things. These are the things. All things are connected to this wirelessly through this to this server. Okay, and as the arrow is bidirectional, data can be taken to and fro. For example, data is taken from camera and sent to the this mobile phone. So in this way, these two things are connected and they interact with each other. So this is the IoT. So this is the center, which is nothing but the embedded system or microcontroller, which plays the role of the to interconnect these things. Understood the concept of Internet of Things, which is nothing but a smart embedded system. That's it. IoT is nothing but a smart embedded system. How we will understand further? What is Internet of Things? So any device, anybody, anywhere, any business, any network, anytime. So when all this connected, Internet of Things forms. So this picture itself depicts what is the internet. So every stage is the research area, okay, or application where you can give the solution. Which are the components of this IoT? Likewise, we have seen the components of embedded system. So here are the major components of IoT. First, devices or things. We have seen here things. These are all things or devices. Okay, so data is to be collected from things or to be given to the things. Okay, so start with the things or devices. Okay, so data is taken from that device or things. Through gateway, it is given to the cloud. Cloud is nothing but your server. Cloud is nothing but a storage area, server, or where data can be processed. So through gateway, as it is the wireless, so this gateway is important. It collects the data and give to the server. So it may be local or it may be a cloud. Once data go to the cloud, what happens over there? Analytics. The data is processed, and based on the processing, it is given back to the things through user interface. Okay, so these are the components of any IoT. So revise again, which are the major components of IoT? Things, gateway, cloud, analytics, user interface. Now you can map your career at any of this stage. Okay, you can be a master of all, but jack of one, or jack of all and master of one. You cannot be master of all. So be a jack of all and master of one. All things should be known to you, but have a mastery on one particular form so that you can explore your career in that direction. So these are all things as discussed. Anything, right from your shoes, your remote, your fridge, your bulb, anything can be connected in IoT. So sensor, how we are interacting with the things? Through sensors only. And in embedded system, we have understood this sensor part. So what sensor devices? Analog sensors, signal amplifier, analog to digital converter, and microcontroller. So as discussed, this complete part is now available in the smart sensors, which can be directly connected to the microcontroller. So sensors are also referred to as the endpoints in the IoT networks. What is the role of microcontroller? Makes the sensor smart. Smart means what? It takes the data from the sensors, process, and can be interact. After taking the data from the sensor, here you can say role of the microcontroller, which is nothing but the embedded system. If you see the building blocks, this is nothing but the embedded system. So this microcontroller, after collecting the data from the sensor, give it to the gateway device. So what is the gateway? Gateway performs edge computation, offloading the server. It gives this data to the server, which is nothing but the cloud through wireless. So there are the different IoT networks where the data can be given to the cloud server through these gateway devices. Let us move further. So these are the smart sensors. As I said, now the sensors are come directly into digitized form. No need of signal conditioning, no need of ADC. Direct you can connect it pin to pin with the microcontroller. So these are all readily available sensors. Again, assignment for you. For third year, second year, study each sensor, how it operates. So you can easily select it for your project, for your application. Here you can see the sensor statistics. Take a screenshot of this particular slide and work on it. So whatever application you are developing, you are not going beyond this boundary or beyond this. All kind of sensors are mentioned over here. You can map it to your application. For your application, which sensor can be taken, or based on the sensor, which application you can develop, vice versa. If you know the tools, you can fight it, or you can give the solution easily if you know the tools properly. So know the sensor, so you can, while designing your embedded system or IoT application, you can connect this sensor to the things and you can collect the data from that particular thing. So this is all about the sensor statistics. Try to understand the working principle of the sensor. Now, being a ENTC engineer, it is expected from you to know the working principle of sensor. When you give demo of your project, you give the demo like salesman. It take the data, it do like that, it does like that. You need to explain what is the role of sensor, what kind of data they are processing. So to understand that, you need to download the data sheet of that sensor so that you can understand what that sensor is contributing in that particular IoT application or embedded system. Coming to the gateway. So we have discussed with the IoT devices and with help of the sensor, we collect the data. Okay. And for specifically IoT, we are doing it with wirelessly. So which are the wireless technologies? Bluetooth, Zigbee, LTE-M, etc. Okay. So with help of this, the data is given to the gateway. We have seen the components of IoT and what is the role of gateway. So this gateway is nothing but your embedded system. It is collecting data from sensors and giving it to the cloud. So after that, if it is a private cloud, then it is given to the wired, and if you are using the internet public cloud, then it is given wirelessly. This is the hardware of any IoT. These board devices are very known to you. That's why I used this. But being ENTC engineer, it is expected that this board should be developed by you as a embedded system designer. Okay, what is there on the board? You have used many times this board, but I'm sure you have not studied the board. Have you downloaded a data sheet of or user manual of this particular board and studied thoroughly all features of the board? Have you done it? In third year, you have done the mini project based on this because we are in pandemic, we have done it online. But how many of you have studied the board completely? So if you study the board completely, you can map each and every action with our microcontroller subject. Okay, so in microcontroller, we are understanding the microcontroller and its features. So these are the different sensor, D2S sensor, which gives the temperature, humidity, and this gives nothing but the camera, which gives the images. And this data is given through wirelessly to IoT Gateway. So whether it is local or cloud, based on that, accordingly data is sent. So if it is local, you can see here it is a Ethernet port. Okay, and if we are giving through wireless, here it is a particular not slot for the SIM or anything. So hardware platform for the node, these are called as the sensor node. So what is the role of this microcontroller? Just to collect the data from these sensors and give it wirelessly to the gateway. And hardware platform of gateway is here. See, both are the embedded system, both are the same boards, but here what is the microcontroller used? It is, let us say, 8-bit processor microcontroller is sufficient for just collecting the data. Whereas it is sending with the speed, high-end microcontroller or microprocessor is used. So on this Raspberry Pi, let us say this is the Raspberry Pi board and this is your Arduino board. So an Arduino Atmel or that's called a sort of microcontroller is used, 8-bit or 16-bit. And for this Raspberry Pi, ARM7 or ARM9, ARM11, such high-end processors are used. In your mobile also, this ARM processor is used. So you can easily develop a mobile using this Raspberry Pi. So that's why ready boards are developed so that you can develop a system and develop a confidence. But being a ENTC student, it is expected from you to develop such boards. So all of you may not use, but at least 10% student should able to work on the hardware. Okay, so we have seen the complete components of the IoT. Each one can have the interest on the separate part or portion of the IoT. So here are the, if you are taking about the sensor node, these many boards are available for the sensor node. So for Arduino, how many boards have a comparative study? How many boards are there? Compare their features, how many IO pins are there, whether they are having, here it is a nano. If you can see, the size of the board is reduced, whereas the features are enhanced. Here you can see the, what is the pin? Third year. This packaging is, which kind of packaging this is?
PDIP.
Dual in line. It is dual in line. And this is square package. Okay, you can see, we have discussed where the size is having constraint, we go for the this type of packaging. And when the size is not important, we go for the this kind of the packaging. That is, so in that way, what are the expectation of your embedded system? You can select the board accordingly. Okay, so these are the all boards. Assignment for you is have a comparative study of features of this board. If you have a comparative study at second year and third year level, you can select appropriate board at your mini project in third year, second sem, and as well as for final year, you can design such boards then. Next, we have seen for the gateway, you are using the Raspberry Pi. Study the Raspberry Pi thoroughly so that you can understand its features and how and which features you can use. So this is the Now, many advanced board are there for Raspberry Pi. This is Pi 3. What is the latest board available for Raspberry Pi 3? Anyone? Karo Google and tell me the answer. Don't be unanswered. Which is the latest Raspberry Pi board and which is the model? Yes, anyone? Are you doing that? Say yes, no.
Raspberry Pi 4.
Raspberry Pi 4 and which is the model?
B.
B.
Model B is there. Now here you need to understand what is mean by model B. Is there model A, B, C like that? What is the difference? We have understood this process in our microcontroller family. What we understand with microcontroller family? What are the feature of existing microcontroller get evolved in the next member? So that is the family. Raspberry Pi is the family, but Pi 3, Pi 4, again different model are the family members of this Raspberry Pi. And why this particular family members are evolved? They are evolved by means of the features. So we need to understand each model, have a comparative study so that you can understand the things while developing your IoT or embedded system. So this is the way that interacts. These are the sensor nodes. Sensors are connected to this basic microcontroller through wireless. It gives to the cloud through this gateway. So this is the gateway and this is sensor. Understood the concept of sensor node and gateway and cloud? These are the three basic components of any IoT. Got it?
Yes.
Yes, ma'am.
Yes, ma'am.
So here is the next way how they interact, connect, data is connected. So relays, routers, sensors, they interact with the gateway and gateway gives the data to cloud or gateway directly interact with the cloud. So through it may be Ethernet or through wireless. Coming to next important part of IoT is operating system. So this many IoT operating systems are available. This is the second assignment and study of area. Compare this operating system so that you can decide which OS to be used. Next, we are connecting the devices wirelessly. So this many wireless technology are available. Which you have select, you need to answer how by means of your requirements, what range you required, what rate you required to receive the data, and what is the frequency band you required. Or this is the spectrum used for that particular transreception. So Wi-Fi and Bluetooth are very common nowadays. LoRa, this particular wireless medium or wireless protocol is introduced, which is again having low power, and see the speed. It is greater than 50 kbs and the distance is greater than 10 kilometer. So here is the 10 meter, 4 centimeter, 100 meter. It is greater than 10 kilometer. This also. Okay, so based on this, you need to decide which protocol you are using for your IoT system to receive the data or to collect the data from sensor. So I have a comparative study of this all protocols in detail. Next, about the cloud server. Last part is the cloud server where data is ultimately going to take and their particular data is being processed, analyzed. That is called as the cloud computing. That is another era. So here, this is the device layer. Here is the fog layer through which data is sent to the cloud, and this is the cloud. You can see the many servers are there. They interact with each other. They have some topology to interact. In final year you may have the star mesh. So how the data is routed, which path, how to select the shortest path. Shortest is the path, fastest is the communication. So in this way all there are different area of research on cloud also, cloud computing, cloud communication likewise. So choose your area of interest where you want to work and start exploring your knowledge in that domain. So which are the clouds? These are the top 10 cloud platforms. Have a comparative study. Many of our students, they have worked on this Google Cloud and they have expertise. So Red Hat, IBM, many are there nowadays in this domain. So have a comparative study which are the best cloud platform available. Do their comparative study, which are the parameters to be considered while comparing, and important part is the cost, because our system should be cost effective. So at each level work on the cost. So these are the another file storage cloud services. These are freely available, but for this they charges you, they takes rent from you. So these are this you use in your daily life. Google Drive you are having your in your mobile phone. OneDrive is there on your phone. So many these file server storage cloud servers are freely available. So we can't get anything freely. The data is with the cloud. And for today's era, most precious is the data. Lot of businesses are there which does the business on data. So the game is of data only. So, and that is the main purpose of introduction IoT. And another way is that we can use the resources effectively and efficiently. That is another purpose of introducing IoT. Second is battery. This is the life of any IoT. So if you see any board, if you have no battery, this all will be dead. So battery is very important for the things as well as for the cloud and the sensor nodes. So for every operation we require the battery. So again, this is the second area of research. We have a comparative study of the battery. It comes from 0.4 inches to at very large size, that is for the EV stations. So you can compare or study the all batteries required for this 0.4 These are used for the wearable devices, and for EV you can see what are the ampere hours rating required to charge the vehicle. So I have a comparative study of this batteries. So most probably when it comes to the small size, lithium ion battery are used mainly. These are the classification of battery, hard case and soft case. In hard case, it comes cylindrical and prismatic. So cylindrical is very known to us. We use this from our childhood in the toys and all. In clock, we used to use these cells only. So, but nowadays for mobile phone, it comes in the prismatic, steel sheet, aluminum shell, plastic shell. So these are the batteries classification. Next is the soft case. This is the pouch. So these are nothing but the pouch cell. So this is about the classification of batteries. Next, I have a comparative study of batteries based on these specifications. So while selecting a battery, you have to consider this specification, specific energy density. How, and being an engineer, always remember, for dealing with any quantity, remember, try to mention the unit of measuring that particular quantity. So specific energy density, what is the unit? WH per kg. Internal resistor, milliohm per volt. So always give the answer with unit. Okay. So in your oral or project, such type of questions are used. So if you practice in this way, there is nothing in your oral. In your oral, they ask all about the basics only. So whatever we discussed from the beginning, if you study in this way, no one can beat you in your orals. So there is the complete understanding of the project. Okay, so go through this different specification. This is specification for different materials are there. This is again the area of research. By changing the material, you can change the charging discharging time of the battery. That is the most important: charging, storage, and discharging. Between charging and discharging, there is the storage period. So, by means of the material, if material change, this particular storage time changes. And more is the storage, more is the durability of any IoT application. Okay, so study this. This is very important slide. You should know the battery specification and battery types. Now coming to the specific IoT application. This is of my interest, Internet of Farming Things. So as farmers are very important for us to improve their yield, let us work for the farmer community to make their farming easy, and how we can help to grow their or improve their overall yield. So for indoor planting, monitoring and management of microclimate condition, real-time climate monitoring should be there, because every crop is subject to condition of the climatical conditions, so which return into the increased production. So these climatical conditions are very important. We need to monitor that. Outside planting, soil moisture and nutrients monitoring, weather data monitoring, smart irrigation control and fertilizer system. If the sprinkler system dispense water only when needed, for example, this prevents the wastage of precious resources like water and electricity. So if we deploy such an IoT system which use efficiently all these parameters, the prosperity of a farmer can improve. Next one is the healthcare. During COVID, we found it very important. So this is again Internet of Wearable Things. Previous was Internet of Farming Things, IOFT. It is a IOWT, Internet of Variable Things. So which are the variable? Basically what we are doing with this variable sensors or IOWT. So IoT device let hospital monitor their patients' health at the home, thereby reducing the hospital. During COVID, this application was found very important because in pandemic, the operation, it was contagious, so it was expected to have a contactless operation, and this is the main application you can explore with this IOWT. In hospitals, smart beds keep the staff information as to availability. We have seen that in pandemic, fake data was available related to beds. Beds are available, not available. If you go to the hospital, it shows on portal it is vacant, but when you go actually, it is not vacant. So know in real time whether the bed is available or not. You can deploy the IoT device and give the real-time data on the portal. Monitoring of the critical body parameters like heartbeats, oxygen level, body temperature, which can mean the difference between life and death. So it is very important. Early care becomes significantly more comfortable with IoT. In addition to the above mentioned real-time home monitoring sensors can also be determined if patient has the fallen or suffering a heart attacks. Many early alert you can give with help of the sensor. Which sensor? Wearable sensors. And these are the wearable sensors available. Based on that, you can give the early prediction or early alert. Smell, focus, test. See, these are the sensors already available. So for test, humidity sensors is used. Speech sensor, ready speech processes are available for that. Pressure, touch, fluid, audio, body balance, sight. So if you know this sensor properly, you can easily develop an application as per the requirement mentioned over here. So study these sensors properly, how they can communicate and give alert. According to that, you can give the solution. And these are the projects for you. These are the application. smart watch, smart shirt, this body control, Bluetooth key tracker, where your child is going, smart shoes, smart socks, smart pant, everything can be made smart using IoT. This is all about the data interaction. Based on the data, you can interact with the particular body part. So you can select any of this as your project. Next is Internet of Automobile Things. Very recently, I have delivered the session to Tata Motors for this IoT. They want to enhance their features by adopting the IoT. So where it can be done for starting, security, logs, infotainment, music, maps, message, lights, truck, camera, many things are there. So you can search Internet of Connected Things. You can give all about automobile things. Search for Internet of Connected Things. So it gives everything about automobile, what you can do with the automobile in IoT in automobile. So one very nice input I got from in that session is that if the car has such a IoT system which will predict whether there is a khadda. What do we say for khadda? Okay, so if we identify that glitches on the road, accordingly, car should adjust its speed. Or if that alert is given to a driver, driver can adjust the speed. So this can be project for you. Try to install a sensor at a appropriate part of the car, which can identify the glitches on the road. And just a minute. Hello. हो 4:30 वाजता आहे मी लेक्चरमध्ये लेक्चर संपलं की इनिशिएट करेन. Okay, so this is the project for you. Everywhere there is a problem and you can give the solution using the IoT. So these are the example, or these are the exploration where you can implement the IoT. Virtual machine, accident detection, stolen vehicle tracking, breakdown on demand, driving behavior, my deals, vehicle valuation. Nowadays cars are resale, so you can do the valuation. Vehicle location, it is already there in many cars. Embedded insurance aggregator, this is very important that car insurance is there while claiming. There is the resistance from the insurance company, whereas also insurance company want the real facts if the owner is cheating or like that. So you can develop such a system that data will be collected about the damage, and it can be given to the insurance, or automatically it will given to the insurance agency. Based on claim can be calculated and automatically payment will be released to the owner. So these kind of projects are available for this IoT. Next is Internet of Industrial Thing. In industrial, many departments are there which are interrelated. You can interconnect those departments with help of this IoT. Industry 4.0 also tells this only, that there should be connectivity between each. Okay, so the tools, daily production, information to manager, information to production department. So in this way, you can develop the Internet of Industrial Things for the industry. This is again very important. Internet of Underwater Things. This is related to sea. You can find out the aquatic animals, you can find out the aquatic plants, do their study, report the data. You can find some cracks in the ship, whether they are available. Many applications can be explored with help of the Internet of Underwater scheme. So from underwater, you can connect with the ground and even to the sky also. Next is Internet of Renewable Energy. This is the renewable, how much energy is generated, what is the quality of the energy. This can be monitored using the IoT application in renewable energy, creating a gearing and sustainable future. Next is This is also area of my interest, Internet of Drone Things. Future is of drone. So if drone communicate with the ground, anything can be done. So nowadays, daily you can find out the news that drone has recently two news I have seen. Drone has successfully delivered the medicine to the patient. Then drone has doing the patrolling for police. Next, drone has with help of the drone in pandemic, sanitizer is sprayed. That also news we have seen in Nashik itself taken place. So this is the future. Here you can see what you can do with the drone if you have IoT, traffic monitoring, border surveillance, then disaster monitoring, not management, monitoring, relaying network, managing the wildfire. You can count how many trees are there in the particular area of the forest, whether cutting is done or not, remote sensing. So there's many applications. You can take one of your project and go ahead. So this is all about the IoT essentials. I would like to share one video to understand the IoT concept, not the application. Many videos are available there, but to understand how IoT works, I like one video that I'm going to share with you. That's why I shared the complete screen with you.
Or IoT is influencing our lifestyle from the way we react to the way we behave. From air conditioners that you can control with your smartphone to smart cars providing the shortest route. Or your smartwatch which is tracking your daily activity. IoT is a giant network of connected devices. These devices gather and share data about how they are used and the environment in which they are operated. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analytics is performed on the data and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product is distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for the repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge. Business Insider Intelligence estimates that 24 billion IoT devices will be installed by 2020, and IDC predicts that IoT revenue will reach around 357 billion in 2019, resulting in a lot of job opportunities in the IT industry. Want to become a part of the IoT revolution? Come and master IoT with EduReka.
So I'm not promoting Edureka. I'm just wanted to show you how it works, and whatever the application we have seen, those are only mentioned. You like the video? Do you like the video? I'm asking you presentation mode of the video. Say yes, no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Why? Because see, what I was delivering, it was a textual here, right? But when you seen same thing visually, immediately it interpreted to your brain, right? So like this way only, we are expecting from final year student to present their project idea in form of video only. Instead of block diagram, now here afterwards we'll represent the project idea by means of video. Agree final year students?
Yes, ma'am.
Very good. Because there are many video making tools are readily available. You have to just use that to explore your idea. With this, you are learning new presentation mode and also new tools to make this presentation, because PPT is now old. Now let us adopt this new methodology to present your idea. Okay. So when you present your project in this idea and go to project competition, it creates a different impact on reviewer, and you may get bonus point for your presentation. So here we try to adopt this way of presentation. So again, there are different essentials of IoT. IoT is not for IT only, unless and until data is taken for the things how IT or computer will process it. Try to understand the role of electronics in the IoT. So feel proud about you. Instead of going into IT sector, focus on the things, because things are important to collect the data. To install the sensors, collecting the data, and the journey of data from things to cloud is the role of electronics. So feel proud of your branch. Focus on the hardware. If you are not, means those who are having potential to study or explore hardware, and suggest those students be there for the hardware, and those who are comfortable with IT, you can focus on that. So that is beauty of ENTC. We are having both in our hands, IT as well as electronics. So we require the device management. Then again, for this complete journey of the data, effective, efficient, shortest path should be given. So there are the many ways to work on cloud path and advanced analytics. After collecting the data, analytics part come based on the result of analysis. Further inference and the controlling action can be taken for the things. Or we need to talk to think again after processing the data. So what is the conclusion? IoT is an embedded system application. So IoT embedded system is integral part of our curriculum. If you clear the concept of an embedded system, you can develop any project with or without IoT. Either you can develop any embedded system, but nowadays everything talk about the smartness, and smartness is nothing but the IoT. So addition of smartness into embedded system is IoT. So no one can shape the life of other. Your success and happiness depends upon your own self. Think for yourself and have a plan of life. Tomorrow is the birthday of Bharat Ratna Sir M. Vishwesharaya, which we celebrate as Engineers Day. We have arranged a very important two sessions tomorrow. Everyone join the session, take the information. Resource persons are very knowledgeable. Many things you can get. Always try to connect such resource person, which will give you hand to go ahead. So expecting your presence tomorrow on the celebration of Engineers Day. So these are the takeaways of today's session. We have seen basic of embedded system, role of embedded system in IoT, everything about IoT, types and application of IoT, and at the end, there is a self-satisfaction. So with this, we'll stop today. Thank you. Thank you for your patience listening. Yeah, over to you, Swati ma'am. Any questions, students? Yes. Are there any questions? If no, we'll stop here. Yeah, Swati ma'am, shall we stop? No question. Very
Yes,
good.
ma'am.
Okay, so give justice to your project. Do something which will give you the self-satisfaction. Do the project for your satisfaction, not for the sake of marks, not for the university. There should be some career development through your projects. All the best. Thank you. And today is the day where importance of Hindi is explored as a Rajya Bhasha. So talk something in Hindi and give respect to Hindi. We'll stop here.